Let's continue to review some probability stuff. Here we have a traffic light, red, yellow, green. 35% of the time, or 0.35 probability of being green, or 0.04 for being yellow, because the yellow is usually a lot shorter. And then we're not sure about the red. Well, what if we wanted to know the probability that it is either yellow or green? Well, they can't be both at the same time. So those two things are disjoint. They have nothing in common. So the probability for that is pretty straightforward, and we're just going to add them together. But you got to make sure that there's nothing in common between the two probabilities that you're looking at. So here we have it. The probability that the traffic light is either green or yellow. So remember, this symbol stands for right there. That stands for or. Green or yellow, add the two probabilities because they could never be the same. But then you say, well, what about red? Well, we only have three options here, green, yellow, and red. So we could just say, well, that's what's left. Let me write that down in more formal mathematical language. So one way we could do that is say, well, we know that the probabilities always have to add up to 1. So this, and whatever that is, we have to add up to 1, because that would be 100% of the time, either red, green, or yellow. There's no other options. Well, one way we could do it is say, well, here's 1 right there, and take the probabilities we have and subtract from 1, and that gives us the probability that is going to be red. Okay, that doesn't seem so bad. Let's use a red light again for another situation. Suppose you leave your house or apartment and you go down the street and there's a red light there, and it's this red light that we're talking about. What's the probability that on Monday you go down, you hit the red light, and you also hit the red light when it's red on Tuesday as well? What's the probability of that happening? Well, let's do this. So because these are independent events, we can just multiply 0.61 times 0.61, and so you have this probability of 0.3721 of hitting a red light twice in a row, Monday and Tuesday. So there you go. Let's take a look at another situation. Suppose you just want to draw a card out of a standard deck of 52, and you're just interested in the card that you pick is either an ace or red. Or actually, it could be both. It could be a red ace. That becomes an issue. So let's look at the probability. And it looks like this. Here we have, this is the or symbol. So it says ace or red. So let's do the probability for if it's an ace. Well, there are 4 aces in the deck, 4 out of 52. And then the red cards. Well, half the deck is red. So we just add to that and say, well, 26 out of 52. So the aces and the red cards. But we don't want to, so right now we're double counting because the red aces are included in this group over here. This group right here. So we should take them out. They're actually in this group and they're in this group. So they're being double counted. And the way we do that, we say, well, let's just subtract the 2 red aces. That's the ones that are in both. And there you go. That's how you figure out the probability. And we end up with it's 28 out of 52. Now that makes sense to me because there's 26 red aces and then there's an extra, or 26 red cards, and then an extra 2 black aces, so 28 out of 52, a little more than half. Okay, there you go. That was a little bit confusing on the quiz that we did last week. So hopefully that clears it up a little bit. So here it is more formally, and it is the probability of an ace and a red card, probability of ace, probability of a red card, minus the probability that's an ace and a red card. So there you go. And that is called the general addition rule for probability. So I was thinking about this situation. Look at this. You've got black and an ace versus provided it's an ace, it's black. Those two things sound pretty similar to me. So let's take a look at the first one. Black and an ace. So we just take a random card out of here, out of this group, right? And how many of them are black aces? 2. 2 out of 52. So we write that down. 2 out of 52. 2 black aces, black and an ace. But then you have this situation over here, which is provided it's an ace, what's the probability that it's black? So let's take a look at what that picture looks like. So that's what this picture would look like right here. Provided it's an ace, what's the probability that it's black? Well, there's only 2 black aces out of, provided it's an ace. So let's take a look. Let's see, 2 out of 4. 2 out of 4. So to me it sounds kind of similar, but very different probabilities, but hopefully we can clear that up. Let's take a look at what if we take this thing and switch it around. Instead of black and ace, we put ace and black. So let's take a look at what that looks like. So here's the picture of this situation. Provided that it's a black card, here's all 13 black cards, what's the probability that we get an ace? So this is where we're choosing from. It's a conditional statement. The condition is that you have black cards. How many are aces? Well, 2 out of the 13. So I'll write that down. And there we go. Those are the 3 situations. Okay, hopefully this clears it up a little bit, how we write these things, and we're going to work with this tomorrow. So if you want to get a jump on our next lesson, I'm going to write this out by hand. So the probability that we have, let's see, it was B given A. So the probability that given it's an ace, it has to be black. So the way that we come up with that is we say, well, let's just take a look at what about the probability that it's an ace. Okay, we're going to take the probability that it is a ace and it's black, like that. And we're going to divide those two. So we're saying, okay, provided that we have an ace, how many of those, basically kind of dividing, how many of this situation are they an ace and black? I'm not sure if I'm saying that right, but this is what we end up with. Let me write this down. So we start out with this. We look at the probability that it's an ace and it's black, 2 out of 52. Now we're going to divide that by the probability that it's an ace, which is 4 out of 52. Now if you remember how to divide fractions, it's going to look like this. Remember when we divide fractions, we invert and multiply. That's one way to look at it. And we get this. 2 over 52 divided by that is really 2 over 52 times 52 over 4. And look what happened. We cross cancel. Remember that? It's all junior high stuff. And we end up with 2 over 4, which is that. So we've just shown that right here. This is equal to that. Same thing. Okay. Now let's do a little bit of algebra with this thing. Now using algebra, pretty simply, I can just multiply both sides by the probability of A and the probability of A. These cancel, so we end up with, I'm going to switch this around, so it's the probability of A and B okay, it's an ace and it's black, is equal to the probability that we have an ace times the probability that we have, and provided it's an ace, it's black. Okay, so this is called the general multiplication rule, and that's what we're going to work with tomorrow. This stuff got a little bit heavy at the end, but I hope all this stuff is helpful, and I really think that these videos will become really helpful when we start to prepare for the big test in the spring. We'll be able to look back and say, oh, I can't remember about these probability rules, and we could just look at that video real quick. Okay, have a great weekend, and I'll see you tomorrow.